Welcome back. In the previous video, I presented the traditional empirical rule, the 68, 95, 99.7 rule, and I briefly discussed why this is a far from ideal tool when one wishes to make approximations using a normal distribution. Here I will introduce the count-by-thirds empirical rule. Again, as like the traditional empirical rule, the count-by-thirds empirical rule is a heuristic or rule of thumb that only holds for normal or bell-shaped distributions. Instead of counting by whole standard deviations above and below the mean, this rule counts by a third of a standard deviation. We'll start at 2/3 of a standard deviation above and 2/3 of a standard deviation below the mean. Within this interval, we capture approximately 50% of the data. If I were to go another third of a standard deviation above that, 3/3 of a standard deviation, which is indeed a whole standard deviation, 3/3 of a standard deviation above the mean to 3/3 of a standard deviation below the mean should capture approximately 70% of the data. The other rule says 68%, but 70% is a far more usable number. And as this is an approximation, 68% versus 70%, I believe the 70% makes more sense as an approximation. Now, if we go 4/3 of a standard deviation above and below the mean, that interval will capture about 80% of the data. Continuing in this pattern, we end up with the following percentages. 5/3 of a standard deviation above and below the mean captures about 90% of the data. 6/3 of a standard deviation above and below the mean captures 95% of the data, which again, this matches the traditional empirical rule that says 2 whole standard deviations above and below captures 95%. 6/3 is actually 2 whole. And last but not least, if you go 7/3 of a standard deviation above and below the mean, this captures about 98% of the data. So the count-by-thirds empirical rule counts off by thirds of a standard deviation, and those thirds of a standard deviations result in nicer percentages or more pragmatic percentages. So whereas the traditional empirical rule counted by whole standard deviations, we're counting by thirds of a standard deviations. A little more complicated, but not that much more challenging. However, the percentages we end up with as approximations go are far more pragmatic and much more useful for percentages that people would actually want to talk about. Now, someone might stop me and say, well, wait a minute, when would I ever be interested in the middlemost 98% of a data set? And that's a fair concern, but if you stop and think for a moment, the middle 98% separates the lowest most 1% from the uppermost 1%. And it is not uncommon that when people are talking about data sets, they're interested in the range or position of the lowest 1% or the range of the upper 1%. So in that perspective, 98% is actually a pragmatic or useful percentage.